Guys, in this video tutorial, I would like to explain about the binomial probability distribution. This distribution belongs to the discrete family of probability distribution, which means that the random variable which follow this distribution is a discrete random variable. There are mainly two types of variable, which is one is continuous and the other discrete. Discrete random variable, they have some jump in the values like mostly they are counting variable like 1 2 3, like number of rooms, number of students, number of pens, etc. And the other is continuous variable, which have no such type of jump points, and they have continuous values. Okay, so let's move to the formal lecture. And uh, binomial distribution has some characteristic, but before that I would like to explain Bernoulli trial. What is mean by Bernoulli trial? A Bernoulli process or Bernoulli trial, an experiment often consists of repeated trials, each with the two possible outcomes that may be labeled success or failure. The most obvious application deal with the testing of items as they come off an assembly line, where each trial may be indicated as a defective or a non-defective item. We may choose to define either outcome as a success. The process is referred to as Bernoulli process. Each trial is called a Bernoulli trial. So what does mean by Bernoulli trial? Bernoulli trial or Bernoulli process. Each trial is called Bernoulli trial and process, that is the process. So the trial which have two possible outcomes like success and failure are defective and non-defective. So this means that in the Bernoulli process, each trial is called Bernoulli trial, but when we repeat these trials n number of times, then we say this is a binomial. This follow a binomial distribution, binomial probability distribution. These are the some characteristic which are, you can say, characteristic of the binomial probability distribution. Uh, I will explain each of them one by one, and if you find these characteristics in any problem, you can solve that problem by using binomial probability distribution. We will explain this later, how we can apply binomial probability distribution. Uh, an outcome of each trial of an experiment is classified into one of two mutually exclusive categories: success or a failure. So this means that the first thing which you need to see in the data, to into the data, that there will be two possibilities of each outcome, that may be success, failure, pass, fail, or whatever you can say, defective, non-defective, maybe other things. But there should be only two possible outcome of each trial. Second characteristic is random variable counts the number of success in a fixed number of trials. This means that we should have some fixed number of trials that we denote normally by small n in binomial probability distribution, and x is the random variable which count these successes. We will explain this also in an example later. The probability of success and failure stay the same for each trial. This means that the probability of success or the probability of failure will remain the same for each trial. This means that if suppose we toss a coin, then the probability of head is 1 over 2 and the probability of tail is 1 over 2. So this remain if you repeat this experiment 5 number of times, 10 number of times, or whatever, the probability of head is 1 over 2 and the probability of tail is 1 divided by 2. So this will remain same for all trial. Third property, and now the fourth property, their trials are independent, meaning that the outcome of one trial does not affect the outcome of any other trial. So I will explain this in terms of the same experiment. When we toss a coin, suppose we toss a coin once and we got head. We toss a coin second time, we may get head or tail, but this is not affected by the first trial. And similarly, the other trial cannot be affected by the previous trial. So this means that these trials are independent. So the trials are independent. So whenever you see these characteristic in a problem, numerical problem, you can solve that by using a binomial probability distribution. Now, before going to this detail, I would like to explain binomial probability distribution by using an example. Let's suppose this means that each trial, each process, in the surrounding or in the environment, you can approximate that by some probability distribution. So my intention here is to explain a process by a binomial distribution. You can solve the probabilities by using simple probability rules, but you can use a probability distribution to approximate those probabilities. And suppose we have large data, large number of outcomes, large number of events, then why not we can use a probability function that is called the probability distribution. So let we have experiment. Let suppose we toss a coin 2 times. This means that the sample space for this experiment will be the sample space for this experiment as S is equal to the first outcome and the first coin may be head, and on the second coin may also be head. There is possibility. The second outcome, the second event can be outcome can be head on the first and tail on the second. The third possibility is tail on the first, head on the second. And the fourth possibility is that both can have tail. So these are all possible outcome of this experiment. Now, let's suppose we have, I will explain little random variable. Now, random variable is a variable whose values can be determined by a random experiment. Suppose we are interested in the number of heads. So then the random variable is x, which denote the number of heads, and how many number of heads are here. You can see here 2 number of heads, here is 1 number of heads, and here 0 number of heads. So the random variable has 3 possible values, 0, 1, and 2. Now, if I want to calculate the probabilities, I mean by just using simple probability rules, the 1 number of heads or 2 number of heads. Let's suppose I denote the event with 0 number of heads, with 0 number of heads, and let B denote the event with 1 number of heads, and let C denote with 2 number of heads. You can use many trial. I use 2 because for simplicity you can use more. Now the probability of A, this means 0 number of head, as NA, which I explained in my previous lecture of probability, and NS. NA mean number of favorable chances for A, and NS number of total chances, number of total outcomes, and number of favorable outcomes. So number of favorable outcome in this experiment with zero head, remember that is only 1. So 1 divided by 4. This means that probability of getting 0 head on both coin is 1 divided by 4. Now the probability of 1 head, that is we denote by B, So that is equal to NB number of variable outcomes for B and total number of outcomes. So again you can see here there are two possible outcomes for this one and this one. There may be H and T or there may be T and H. So the probability for this case is 2 divided by 4, which means that probability of B is equal to 1 divided by 2. Now the probability of C and C divided by NS. Number of favorable outcomes for C, number of favorable number of total outcome. So you can see that there only one such type of event which can have two heads and the total number of outcome is 4. So this probability is 1 divided by 4. This means that probability of C is equal to 1 divided by 4. So this is the solution by using normal probability rules. Now I would like to apply binomial probability distribution to this problem, but you need to see whether this problem satisfies the rules, the characteristic of binomial probability distribution or not, which I explained earlier. So the first one was each trial should have two possible outcomes. In this experiment, each trial have two possible outcomes, head and tail. The first one is done. The second one was, you can see from here, what was the second one? The second one, the random variable counts the number of success and affects number of trial. So you can see that our our success for us is number of heads. So x is a random variable which has these values. There are zero number of success here. There are one number of success and there are two number of success. Remember, the total number of trial is 2. We repeated this experiment 2 times, so that is n equal to 2. So the second is satisfied. The third one is the probability of success and failure stay the same for each trial. This means that, of course, when we toss a coin, the probability of head is 1 over 2 and the probability of tail is 1 over 2, and this remains for each trial. So we have two trials. For each trial, this probability remains the same. And the last one is the trial are independent. So of course, the trial are independent. That does not impact the result of other trial. So this is the problem of binomial probability distribution. So we can use binomial probability distribution to calculate these probabilities. I will calculate these probabilities and you will see these probabilities will remain the same. But before that, I would like to explain briefly the function of binomial probability distribution, because we need to use that. Okay, so this is the definition of binomial probability distribution. A Bernoulli trial can result in a success with the probability P and a failure with the probability Q, which is equal to 1 minus P. Then the probability distribution of binomial random variable x, which satisfy those four properties characteristic, the number of success and n independent trial. So x is the number of success, n is the total number of trial, and we denote this by b, that's for binomial. X is a random variable, semicolon, n is the total number of trial, p is the probability of success. So this is the random, x is the random variable, and n and p are the parameter of this distribution, which is equal to n cx or n combination x, p power x, q power n minus x, and x is 0, 1, 2 up to n. This is the number of success. So this is the function of binomial probability distribution. Now I will apply this function. Now by using binomial distribution, what we need in binomial probability distribution, that is denoted by x, n and p, and that is n combination x, p power x, q power n minus x, q is equal to 1 minus p, and x is equal to 0 up to n. So what is given in the problem? In the problem, n is given. We repeat the experiment 2 times, remember. So n is equal to 2. P is the probability of success, and we are interested in number of heads. The probability of head is 1 divided by 2. This means that Q is equal to 1 minus P. 1 minus 1 divided by 2, which is equal to Q is also equal to 1 divided by 2. So these things are given. And now we need to calculate the probability for x. Remember that x can take values 0 number of head, 1 number of head, and 2 number of head in this experiment. So what you need to do, you need just to put these values, different values of x in this function, and you will get the probabilities. Let's suppose x equal to 0. Now this function can become 0, n is 2, I already told you, and p is 1 divided by 2. Just put these values. N is equal to 2, x is 0, p is 1 divided by 2, and x is 0, and q is 1 divided by 2, and n is 2, and x is 0. Now you can expand n combination x or 2 combination 0 as 2 factorial divided by 0 factorial and to 2 minus 0 factorial. You can see like this ncx. You can expand this n factorial x factorial to n minus x factorial. And then this is 1. Anything that's to the power 0 equal to 1. 1 divided by 2 power 2. So this is 2 factorial divided by 2 factorial and to 1 divided by 2 power 2. So probability of x equal to 0 with this parameter is equal to 1 divided by 4, which is similar, which we calculated by using the normal probability rules. Now x equal to 1. The probability distribution function of binomial distribution can be written as, now just put x equal to 1, 2, 1 divided by 2. Then this means that now n is 2, x is 1, p power 1 divided by 2, which is already given, power 1 now, and 1 divided by 2, that is q equal to 2 minus 1. This is now 2 factorial. You can expand using this formula on the side I mentioned, 1 factorial and to 2 minus 1 factorial. This is 1 divided by 2 and this is 1 divided by 2 power 1, so this is 1 divided by 2. Now 2 factorial divided by 1 factorial and to 1 factorial. This is 1 divided by 4. So 2 factorial you can expand like 2 and to 1, 2 multiplied by 1, 1 multiplied by 1, 1 divided by 4. So this means that this probability, this is 1 divided by 4. This means that the probability of x equal to 1 to 1 divided by 2 is equal to 1 divided by 2, which is similar to the same to the probability which we calculated by using simple probability rules. Now x equal to 2, so this is 2, n is also 2, and p is 1 divided by 2. So this is the function you can write 2 combination 2, 1 divided by 2 power 2 and to 1 divided by 2 power, n is 2, x is 2, so this is 0, 2 factorial divided by 2 pictorial and to 2 minus 2 pictorial. 1 divided by 2 power 2 to 1 divided by 2 power 0. So this means that this is 2 pictorial, this is 2 pictorial and to 0 pictorial, and this is 1 divided by 4. This means that this can be crossed, so the probability is 1 divided by 4. 2, 2 and 1 divided by 2 is equal to, which is same as we calculated by using the normal probability rule. Now the question is, why we are using binomial probability distribution? The reason is because we will have large number of trials. This was 2 trials and we did the probability. This was the problem of 2 trials and we did the probability, calculated the probability by using the probability rules, and this can be approximated by using binomial distribution, as this problem satisfies the characteristic of binomial distribution. So you have n number of trials, large number of trials, you can use this probability function, which is very useful in such type of problem, to calculate the probabilities instead of calculating all probabilities by using that probability rules. So this is the advantage of these these statistical distribution. Okay, now this was an explanation that what is the advantage and how we can approximate a real system problem by using distribution function. So you can use other distribution for other type of situation like Poisson, normal, beta, gamma, and other distribution. Now I have some problems, so I would like to explain these problems, solve this problem by using binomial probability distribution. The first problem is the probability that a certain kind of component will survive a shock test is the 3 by 4. This is probability. Find the probability that exactly 2 of the next 4 component test will survive. You need to understand the problem. If you don't understand, you cannot solve the problem. So try to understand the problem. The probability, this means that the success is that the component will survive a shock test. So this means that P is the probability of success, that is 3 by 4. And now we need to calculate the probability of exactly 2 of the next 4 component test to survive. This means that exactly 2 means that X is equal to 2 success, and the next 4 component tested survive. This means that 4 is the total number of trials. Of the next 4 means 4 is the total number of trials, that is n is equal to 4, x equal to 2, and p is equal to 3 by 4. So this is a very simple problem. We can solve this very easily. Let's do it. This means that problem. The solution to this problem is problem that is p is equal to 3 divided by 4, n is equal to 4, x is equal to 2. So this means that we can calculate by using binomial distribution that x is 2, n is 4, and p is 3 divided by 4. Remember that q is equal to 1 minus p, which is equal to 1 minus 3 divided by 4, which is equal to 1 divided by 4. So this is equal to, you remember the binomial function as ncx, 4 combination 2, 3 by 4, which is p, and x is 2, and to 1 divided by 4, and to n minus x, so 4 minus 2. This means that 4 pictorial, 2 pictorial, and to 4 minus 2 pictorial. 3 by 4 square and to 1 divided by 4 square. So this means that 4 pictorial, 2 pictorial into 2 pictorial, and this you can write 3. Okay, we can write now like this: 3 divided by 4 square to 1 divided by 4 square. So you can now simplify this: 4 multiplied by 3 multiplied by 2 pictorial, 2 pictorial into 2 into 1, because 1 will be crossed with this 2 with this one, and now 3 divided by 16 and 2 1, this is 3 multiplied by 3, and this is this is by 16. So this probability, you can say this will equal to, you can again this with 8, and this will 3 multiply by 3 multiply by 3, and this is 8 multiplied by 16. So you can solve this probability easily, that this is 27 divided by 8 6 48. This look like this. So you can solve this simple by using calculator. 27 divided by 128. So you will get this probability 0.2109. This is the probability, the required probability. Probability up to 4 and 3 divided by 4. You can see the problem again and you can interpret the result. So this is the solution to this problem. This is another problem, which is, I will solve this. I will just read the statement. There are 5 flights daily from Pittsburgh, West USA Airways, into the Bradford, Pennsylvania regional airport. Suppose the probability that the flight arrives late is 0.20. What is the probability that none of the flights are late today? What is the probability that exactly one flight is late today? So here the success for us is late, and there are 5 flights daily from Pittsburgh. So this means that n is equal to 5, and the probability of success, which is for of course for us that is late, is success. So p is 0.20. And now they're asking what is the probability that none of the flights are late today? What is the probability that exactly one of the flight is late today? So let's solve this problem. Problem that is p is equal to 0.20, the probability of late, n is equal to 5, and we have two questions: x is equal to 0, x is equal to 1. Again, you can see this problem is the binomial problem because there are two possibilities. Maybe the plane is late or not late. And you can see the other conditions are also satisfied. So part A. For part A, this is equal to x is 0, n is 5, and p is 0.20. This means that q is equal to 1 minus p, which is equal to 1 minus 0.20, which is equal to 0.80. So q is equal to 0.80. This means that now n combination x, 5 combination 0, you can solve this is equal to 0.20 power x, x is equal to 0, and 0.80 power 5 minus 0. So this is equal to 5 factorial divided by 0 factorial and to 5 minus 0 factorial. This is 1, everything is to the power 0 equal to 1 and 0.80 power 5. So this is now simply equal to 5 factorial divided by 5 factorial and 0.80 power 8. So this one can be cancelled and this is the probability. You can simplify this just by taking the power 0, 5 and 0.20. So this is the probability for this question, and please solve for part B that I will just write uh, the values and you can simplify. That is x is equal to 1, 5 and 0.20. Just need to put the values 5 now instead of 0 equal to 1, 0.20 power 1 and 0.80 power 5 minus 1. You can simplify this question, you can get the probability for that there is exactly one plane left. This you can solve simply. Now the other problem. Okay, so now this problem is interesting because there are 5 possibilities. I would like to explain this on the slide. As you know, you already understand what is mean by how we can solve different problems. The probability that a patient recovers from a rare blood disease is 0.4. This means that recovery from the disease is success for us. So that means that probability of success, that is P is equal to 0.4 and Q is equal to 0.6. If 15 people are known to have contracted this disease, this means that the total number of trials here is 15, so N is equal to 15. What is the probability that the first one question is at least 10 survive? B, from 3 to 8 survive, and C, exactly 5 survive. So you can solve this problem um, just by doing. Okay, now this problem, this means that in this case P is equal to 0.40, Q is equal to 1 minus P, which is equal to 1 minus 0.40, which is equal to P is equal to 0.60. We have this, we have P, and N is equal to 15. And now there are different questions for which we need to calculate the probability. So A is at least 10 survive, 10 to 8 survive, exactly 5 survive. At least 10 survive. B, 3 to 8 survive. And C was exactly 5 survive. Exactly 5. This means that at least 10 mean x greater than 10. Remember, we need to calculate this probability. This means that x, the success value is 3 to 8, including, and exactly 5 mean x is equal to 5. So I think now the problem is a little simple. You can do now this by doing. This means that this means that probability of x greater than equal to 10 mean that we need to use all the values until 15. That is sum of these probabilities by binomial random variable I from 10 to 15. That is x, because these are the values for this. N is equal to 15 and P is 0.40. What does it mean by this? This means that we need to calculate the binomial probabilities for each value on this variable. The first value can be 10 now, because we need to put x 10, 15, 0.40, plus the second value as x is equal to 11. Now 15 is n and 0.40. The last value will be probability of, that is 15, n is also 15 and p is 0.40. Now you already know that how to explain, to calculate this part, calculate this part, and calculate this part. So you already know how we can do this. So you can do this by yourself just using calculator. And this probability is equal to 0.0338. 0.0338 probability of x greater than equal to can survive. Part B. Part B. This means that we need probability the random variable is greater than 3 and is then equal to 8. This means that we can sum I from 3 to 8. 3 to 8 binomial random variable, n is 15 and p is 0.40. So this means that now we will start from 3. Binomial 3 n is 0.40 plus binomial now 4, 15, 0.40, and we will go until binomial. Now by the way, we need to go to 8 only. 15 is n and 0.40. Now again, you know that how to explain, how to solve each of these terms as we did already. You just need to put in the binomial distribution function x3, n15 and p 0.040 and q is equal to 0.6. So you can solve this. Probability will be 3 to 8 recoveries. This probability is 0.8779. 0.8779. This is high probability as compared to the other. Now see, this part is a little simple. X is equal to 5. This means that we don't need to sum because we have only single value. So x, that is 5, n is 15, and p is 0.40. So what you need to do, I can help you now in this. You can solve each of these terms like this, because this is a single term and these have many terms, I mean 3 to 8. So this means that n is 15 binomial distribution and c5 x5, p is 0.40 for x, and q is 0.60 for 15, that is n minus 5. So you can simplify this probability and you can get our value for this probability is 0.1859. 0.1859. Probability of exactly 5 recoveries. So you can solve each of these part, and by the way, you can use program, computer, calculator, or software like or Python, so you can solve these probabilities. So this was all about these probabilities, and here you can see that you can solve this by using this method. I will just explain this how. Remember that there are some properties of probability distribution. Properties of probability distribution. Suppose X is a random variable which follow a particular probability distribution, then there are two properties. In discrete case, we denote like this: xi is greater than equal to 0. This means that for each value of the random variable, the probability is greater than or equal to 0. To I from 1 to n, probability of x is equal to xi is equal to 1. This means that the sum of the probabilities for all values of x is equal to 1. So, using this property, you can solve this problem as well. They're asking about that at least 10 will recover. At least 10 means from 10 to 15 because the maximum is 15. So you can use this rules that for all values, I will write right here that how you can solve this part by using there. This means that using the second property that x uh, probability of x greater than you can say I will write like this. Okay. Okay. So this means that x less than 10. This mean from 0 to 10 because the value is and x greater than 10. Greater than or equal to. This means from 10 to 15. The sum of the probability pass all values is equal to 1. So this means that you can calculate, we need this probability. So this is equal to 1 minus probability of x less than 10. In other words, this means that you need to calculate the probability of x from 0 to 9. You will see this is from here 0 to 9. So the probability from 0 to 9. So you can use this formula as well, which is mentioned in the problem, in the solution. Now, the other important thing is about this distribution is the mean and variance. What are the mean and variance of this probability distribution? Mean and variance. I will just write the result and maybe in the other video I will try mean and variance of binomial probability distribution. Mean of binomial probability distribution as NP mean that number of trial multiplied by the probability of success. Variance of binomial distribution is NPQ. This means that number of trials, probability of success and probability of failure. So simply when you know these things, you can just calculate the mean and variance for this distribution. So we have a problem here. The probability that a patient recovers from oral blood disease is 0.4. If 15 people were known to have contracted this disease, find mean of this process, standard deviation of this process. This means that the p-value is 0.4, probability of success is 0.4, and n is 15. So this is a very simple problem. In this problem, n is equal to 15, p is equal to 0.40. So mean of this distribution, that mean number of, you can say mean number of success, yes, so that is n multiplied by 0.40. You can calculate this, and variance or standard variance is equal to 15 is 0.40. This means that q is equal to 0.60 multiplied by 0.60. So we can calculate this by using simple calculator that how we can do this. 15 multiplied by 0.40, 0.40, that is equal to 6, and then 15 multiplied by 0.40 multiplied by 0.60, that is 3.6. But remember, this is now variance, not standard deviation. So standard deviation of this variable is equal to square root of the variance. But remember, you need to consider only the positive quantity. So this you can calculate 3.6. You can just use simple calculator and get this value. So this was all about the binomial probability distribution. I will summarize what we have learned in this tutorial. We learned the theoretical definition of probability distribution. First, we learned about the Bernoulli trial, the Bernoulli process. Then we learned about what are the characteristics of binomial probability distribution, how we will know that this problem is a binomial probability distribution. Then we had some problems to solve those problems by first we investigated where these problems can be solved by a binomial distribution. So what you need to do for that, you need to see these four characteristics of binomial distribution in those specific problems. And then at the end, we learn what is the mean of binomial distribution and what is the variance or standard deviation of the binomial distribution. And then we solve the problem to understand what is mean by there. So this was all about binomial probability distribution. Thank you very much for watching and see you in the next video.